Hello everyone, good afternoon and welcome to today's webinar on Digital Twin Maturity Model from BIM to Intelligent Operations. Thank you all for taking the time to join us today. We are excited to have such great audience with us. I am Pragya Gupta, Product Marketing Manager, Neilsoft, and I will be your host for today's session. Before we begin, a quick note. This session will be around 45 to 60 minutes. We will have a question and answer at the end, so feel free to drop your questions in the chat. Today, most facilities have BMS, sensors, and data, but the challenge lies in converting that data into actionable intelligence. In this session, we will explore how organization can move across different levels of digital twin maturity from static models to intelligent, data-driven operations. It's my pleasure to introduce our speakers for today. We have Mr. Dhananjay Dixit, Senior Product Manager, Neilsoft. With over 25 years of experience, he has led global programs, managed client managements, and delivered strong business results. He is skilled at connecting business and technology to drive effective solutions and outcomes. Dhananjay brings hands-on experience across the software lifecycle and is known for leading teams with clarity, collaboration, and impact. Welcome, Mr. Dhananjay. And we have Mr. Shripad Lale, President, Neil Automation. Shripad has 36 years of experience in the manufacturing IT industry. He has been part of projects across a broad range of manufacturing IT stack, including PLC, SCADA, advanced process control, energy management, manufacturing execution, and manufacturing analytics across a wide range of industries, including food, pharmaceuticals, oil and gas, water, wastewater, mines and minerals, and power generation and distribution. Welcome, Mr. Shripad. We are excited to have you both. With that, I would like to invite Mr. Dhananjay Dixit to take over the session. Over to you, Didi.
Okay, great. Thank you, Pragya, for this lovely introduction of me and Shripad. So in today's session, me and Shripad will be talking about the digital twin maturity model, which essentially is, first of all, starting with what is the digital twin, how exactly the digital twin, what are the benefits, what are the different levels of digital twin, and how digital twin evolves over a period of time, and what is the right stage of digital twin where we will start seeing benefits and we will get the value out of it. So with that, I'll first start with essentially just talking about the digital twin as a concept and how it started. Okay, so if we go back maybe about 40 years ago, it was first NASA who essentially actually did a physical twin of their Apollo 13 mission when the astronauts faced issues while they were orbiting. That's where to troubleshoot the issues and make sure that they provide the right decisions to those astronauts so that they can come back home safely. That's where the NASA first used a physical replica of the capsule itself, and that's where they tried out various options, and then they provided those inputs to the astronauts where it helped astronauts to come back to the Earth. So that was the first. While at that time we never talked about it, or they never termed it as digital twin, but if we really closely look at it, actually that was a replica that was created to essentially help in troubleshooting and make finer decisions and split-second decisions. So that's the first example I will say. The second example I can say is when we talk about the air traffic controls, we do see a lot of these ATC towers near Mumbai airport and a few other airports. And nowadays these are exceptionally technologically very advanced towers where they have the right type of technology, all the recent latest technology, secured, military grade technology that they are used. But if we go back 50 years ago, 40 years ago, that is where when the radio communication technology was not as good as what it is today. They actually used to have the wooden maps of the airport itself, where it will show all these taxiways, runways, different gate positions, and they will have few small LED lights or few lights there which would blink if the gate is closed or if the gate is available. The runway will glow if the aircraft is on the runway, right? So if you really see, that is again a replica that was created. Although again it was never termed as digital twin, but these were called as the shadow systems of the physical reality. Now that physical reality can be a building, can be an industrial plant or a factory, or critical infrastructure like data center or airports, right? And as we moved on, then as the industrial revolution came, we started using the PLCs and SCADA, where it was not just the monitoring, but implementing some discipline into the operation. So using PLCs, we could do some programming, we could embed some logic into the way the systems operated. And that's where we can see that it was more like a 2D twin of the systems, where we could see different equipments, different systems that are within the facility, how they are operating, whether they are on, off, and maybe scheduling them. So those are the examples of digital twin, which I would like to term them as more like accidental digital twins, which helped in doing decision making in split second and ability to control few of the things. So that's a background about digital twin, as what digital twin is, where it was 40 years ago, and now we will talk about what exactly the digital twin is all about. So now, as we see, most of our new constructions that are happening or new facilities that are getting built, they use the 3D technology. Okay, BIM is something which is now widely accepted across globe. In some countries, it is now mandated that BIM must be there before even starting the construction, right? So that BIM essentially gives the 3D geometry of the facility, but at the same time, it also is enriched with a lot of asset data, specifications, different parameters, different settings that are required. And this data essentially is definitely gathered, designed during the design time. Definitely it is used during construction, but often that data then remains isolated and hardly used in the operations and maintenance. So first thing I would like to confirm, or I would like to put that in our mind, is just having a 3D model is not a digital twin, because here we are able to visualize it, but we are not able to effectively make use of that rich data, which is part of your design, which is part of the specifications during your operations and maintenance. So first thing, 3D model, just having a 3D model is not going to, we will not be able to term it as a digital twin. Secondly, the dashboarding part of it. Of course, now with this, within the facility, we can add sensors, we have PLCs and SCADA systems where it will help us to understand the real-time data of various systems that we'll have. And typically, as I said, this is more like a 2D system where we will have cockpit, and maybe there's a BMS room where they will be able to see, okay, which pumps are running, when they will run, what are the different water levels or the resources, measure the resources, and so on. Again, that is not a digital twin, because the insights that they get are more reactive, because after some incident happens, then they will understand, okay, this incident has happened, and probably they will take corrective actions against it. So that is where it's not going to essentially help in preventing some incidences or making intelligent operations or intelligent actions. So again, dashboarding is not a digital twin. But when we talk about the digital twin, the living part of it, that is where it's not just the replica, but that is where it is actually giving out the live performance of the facility, whether it's a building or a plant or a factory, but it is giving out that information. And based on that information, the analytics part of it, the data is analyzed, and there's a bidirectional flow between your physical asset and the 3D model or the digital twin. That's where it's a true twin. That is where it is completely integrated with the physical facility. It's a true replica, but a living thing. So that is where the digital twin is. So just 3D model or just able to dashboard it is not going to be sufficient for a true digital twin, but it must be live, it must give out insights. Now with that, I would like to invite Shripad to talk about different levels of the digital twin. what is the journey? Like we talked about shadow in the beginning, where NASA created the Apollo 13 capsule, and the air traffic controllers created different boards or wooden replicas of the airport models to understand it. So which is more like a shadow. But from moving from shadow to living twin, what is the journey? Is Shripad, if you could take us through that.
Thank you, Ricky. So in the next few slides, we'll try to see, get some idea about how we look at digital twin, what is the structure of a typical digital twin, what is the purpose of the various layers, and also what value each layer derives. So what we see on the screen is a 4-layer model of a digital twin. So at the bottom layer is usually a static representation of a physical world. So this usually comes in the form of either a BIM model or a CAD model, and more often than not, what you have there is the representation of the physical structure in terms of dimensions, in terms of entities. So if there is a building, then this structure will contain the walls and the doors and the staircases. If it's a manufacturing unit or it's a process plant, then it will also contain things like conveyor belts, it will contain motors and drives and things like that. But it is still limited to the physical representation, a digital representation of the physical world from a drawing perspective. Apart from the drawing, it also contains the metadata at this level, which means that if there is a motor, then information like the make of the motor, model of the motor, the information about where the parameters of the motor are stored. So why it is called metadata is because it is data about data. So the real data is the RPM, current, vibration, temperature, but this layer contains information about where to pick up the RPM from, where to pick up the current from, and so on and so forth. Also, it contains information about some transactional information, like for instance, when was this motor maintained? When was the maintenance done for this motor? Who did the maintenance? Which person did the maintenance? How much time did it take? What spares were consumed? What activities were done during the maintenance? Now, again, this layer contains information about where the maintenance information is available, not the physical maintenance information itself, right? So it is structural model of how it looks, what are the dimensions, and all the addresses. Where is the real-time data store? Where is the transactional data store? Now, once you have this, you can then move to the next level, which is called a digital shadow. The digital shadow is a layer where the metadata is used, is consumed by another software entity, and the real-time information is pulled and superimposed onto level 1, right? So now there is a software package that looks at the metadata, finds the tag number, tag name for let's say motor RPM, goes to an external system like a SCADA system, pulls the motor RPM, and it superimposes the motor RPM on level 1, right? Now when you look at layer 1, you will see the layer 1 alive, right? You will see a motor, but on the motor you will also see the RPM. On the motor you will see the current. On the motor you will see the maintenance information. So that these two levels combined, you get what we call the digital shadow. Now the digital shadow is still one-way flow. For instance, what happens in the physical world is reflected in the digital world, but what happens in the digital world doesn't really reach the physical world. That is when the digital twin level comes in, where there are correlation models that are built which have a correlation between what is the correlation between the load on the motor and the current consumption of the motor, or what is the correlation between the load on the motor and the vibration of the motor. So these correlation models are built. They are typically either ML models or AI models, and once you have this, you have the ability to do what if analysis. So if there is a motor that is driving a conveyor belt, and the conveyor belt has a load and the motor has a current, eventually if you keep on loading the conveyor belt, there is a good chance that the motor will burn. Using the digital twin, because we know the correlation, you can actually simulate how much can you load the conveyor belt before the motor burns. And you can actually burn the motor in the digital version without doing anything to the physical motor. So this is where the value comes in. You can push boundaries, you can find out how something will behave, and then you can do what if analysis. So that level 1, 2 and 3, with that you will get a digital twin. But from an industry 4.0 perspective, there is a final level which is called autonomous, right? So this digital twin is still driven by people. But if you can imagine, if we want a really perfect replica of the real world really doesn't depend on anybody. The real world is kind of running itself. So at the living twin level, that understanding of what is happening and then predicting what will happen in the future and what is required to prevent defects, that loop is closed, and you convert the digital twin into an autonomous operation. So up to digital twin level, you will probably have a very good ability of seeing defects, seeing anomalies. But when you go to living twin, you go into the realm of defect avoidance. So the defect will not occur. The defect will be predicted long before it occurs, and corrective action will be taken so that the defect doesn't occur at all, rather than actually correcting the defect once it is done, right? So with that, let's quickly go to the next step. So this is we call it a Jenga representation of the digital twin, and this all kind of explains what I just said in a little more detail. Is that there is at the bottom, there are bottom two blocks of the Jenga are the BIM model and the facilities model. So BIM model is a digital model. It contains the structural definition, which is the CAD, plus it also contains all the metadata. And then the counterpart of the BIM model are the physical facilities. Now these physical facilities are not part of the digital twin. They are part of the real world. So they consist of the building management system, the manufacturing execution system, the SCADA system, the process control system. These are real systems that exist in the real world, and the BIM model is partly a digital version. On top of that, we have Nilsoft has a platform called Energy and Environment Management Monitoring Platform, EEMS we call it. So the EEMS platform is the software component that is responsible to create the digital twin. So what EEMS does is it reaches out first into the BIM layer, it extracts all the metadata. Based on the metadata, it reaches out into the physical facilities world, which is it makes a call, either an OPC call to the SCADA system or a web service call to an MES system, and it reaches out into that, pulls the real-time values and superimposes the real-time values onto the BIM layer, and that is how you will see the BIM layer coming alive. So that's the purpose of the Energy and Environment or EEMS platform. Once this infrastructure is ready, that you have the information defined in the BIM model, the real-time data available in external systems, and an entity that is able to marry these two, then you can enable several use cases. So these are just 3 use cases. There will be many more. So one of the use cases that can be enabled with this infrastructure is asset maintenance. Now that you know when a particular asset was maintained, like let's say a motor, and you also know real-time information like how many hours that asset has been run, and you know parameters like mean time between failures and mean time to repair, MTBF, MTTR. Based on that, you could actually make very smart decisions about when the asset should be maintained. So you don't have to go to the 2 extremes of maintenance, which is at one extreme is breakdown maintenance, at the other extreme is preventive maintenance, which means that you keep on maintaining it at periodic intervals. Now you can now start doing condition-based monitoring and also combine that information with maintenance information that was done, transactional data from their maintenance management system, and you can exactly optimize the maintenance schedule. The second use case that can be enabled is predictive analytics. Now predictive analytics is for any variable. You can have predictive analytics for energy consumption. You could have predictive analytics for HVAC management. So any value that you want to optimize. Typically energy consumption is, once you have the infrastructure, You can predict how much energy is going to be consumed by which part of the building or which part of the plant at what time. And based on that, you can enable certain energy sources. You can enable either energy coming from the grid, or energy coming from solar panels, or energy coming from diesel generators. You can also factor in things like variation in pricing. In India we don't have it, but in several Western countries, energy pricing depends on the time of the day. You have low prices during the night, high prices during the day. So you could actually, using predictive analytics, you can actually decide at what time of the day energy should be should be taken from what source, whether from grid or a DG set, or from a solar panel or a wind turbine. And then finally, you can actually have an energy and environment management system where you're applying these same principles to environment management, where you're trying to optimize on or reduce on greenhouse gases. You can optimize on noise, dust, things like that. And there is a new trend that we are seeing in the market, where there is a concept called wellness index that gets calculated, which just defines how nice it feels to be in a building. So wellness index is a combination of oxygen content, carbon dioxide content, noise, dust particles, and several other components that basically have an impact on a person's health, or for that matter, even a person's mood. And countries like Singapore are beginning to calculate this wellness index in real time for places like schools, especially where small children are there. They are beginning to focus on these things. So those kind of use cases can be enabled. Now with the use case, so then once the platform, BIM physical facilities, the EMS platform, and a single use case is brought together, you get what we can safely call the digital twin. Now this digital twin still is a generic digital twin. It has all the infrastructure, it has all the paraphernalia to make decisions, but it is still, it's still a generic twin that works for anything. You can further refine it by orienting it to a specific industry vertical. So that is the top layer of the Jenga pieces, is that you can then configure that digital twin for a specific industry vertical, like critical infrastructure, like for instance hospitals or airports, or you could actually configure it for an industrial plant or factories, or for commercial buildings like malls and shopping malls or theaters, because each of these industry verticals have a very, very specific asset hierarchy. For critical infrastructure, it could be, for let's say hospital, it could be building, wing, ward, room, and part of the room. For airport, it could be the building, terminal, concourse, gate. So the asset hierarchy does differ. So you could actually configure that asset hierarchy specifically for an industry vertical. Yeah, you can go ahead. Yeah. So now we always talk about a journey, digital twin as a journey. So it makes sense that if you are on a journey, then you don't want a 5-6 step journey where the first 5 steps are worthless and then the 6th step delivers tremendous value. You really want to have a journey where every step delivers some value, right? So we want to kind of highlight here the value that every step delivers. So while you are taking only one step, you're not at digital twin, but whatever investment is done in that journey at every step has a certain return. So for instance, at the BIM and static data level, what you have is a rich asset and data specification. So one of the things that this does is it moves the specification of your data from out of your paper or out of the files or out of the multiple Excel files that are there, and it moves it into a centralized BIM model. So that is the value that you get after step number 1. Once the physical facilities are connected, then you have, or physical facilities are created, you have a central nervous system where all real-time data resides. Then the energy and environment management system brings these two together. So EMS platforms reads the real-time data, superimposes on the BIM material, and now you have got a first semblance of what we call a digital shadow. And then moving up from the digital shadow, you can then start enabling your energy and environment management goals, which is tracking of greenhouse gases, environmental compliance, automated reporting, what if analysis, and then finally the top layer will give you the full predictive digital twin that will enable you to make what if decisions. So every layer, it is a journey, it is a reasonably long, maybe over a period of maybe a year or so, but each level has a certain value that it delivers from a digitalization journey perspective. Yeah, thank you, Didi. You can take over from here.
Okay, good. Great, thanks Shripad. And now that we have seen the various levels, the maturity levels of the digital twin, starting with how we can make use of the BIM data, how we can make use of the existing systems, how we can collect and essentially get a unified way in which all this data, all these systems which are isolated, how we can collect them together and have a centralized view or centralized vision for the entire facility that we saw. How this data that we are collecting can be further utilized for your energy optimization, environmental wellness, and essentially how about we can do a more of like proactive asset maintenance and also get insights which can help in further streamline your operations for the entire facilities. And that is where Neilsoft has developed and launched a platform called as EnviroOptimus, which essentially is an environment and energy management solution built specifically for the digital twin enablement. So it's a unified digital twin platform which helps in establishing your infrastructure into a living digital twins, taking into consideration all the existing assets. Now, when I say assets, the BIM is going to be an asset, the existing systems are going to be an asset, and on those assets, how we can build a digital twin. And that is where this platform helps to take your design data, how this design data can be taken to operations, the data that is getting collected, how that data can help in doing better decisions, taking proactive decisions, and how we don't just remain in the monitoring mode, which is more of a reactive, because after a certain event has happened, then we do some corrective actions, which is a more of reactive behavior. But then how do we move that into a management level where it is more of a proactive level, where we try to avoid incidences, we try to avoid unexpected surprises, we want to avoid any downtimes, right? So that's where moving from reactive to proactive mode. So that's where the EnviroOptimus as a platform is a unified platform to enable your digital twin and implement digital twin at the topmost level where it is a living digital twin, or even at an intermediate level where it is fulfilling specific requirements of the end user. As Shripad was saying, like some users may only want digital twin for automating their compliance reporting, certifications, and so on. So our platform enables that, where we can extend it to make it a complete living digital, or we can restrict it as per the scope of the final end users. Now, this is the enabler platform where it has a connectivity layer where it can connect to various of the existing systems, or we can apply various type of new hardware to it, IoT hardware, which is like different type of sensors, energy meters, smart meters, or for industrial type of like flow meters, pressure meters, and so on. And it supports all of the industry standard protocols like Modbus or OPC or DLMS. So that's where it's more like a plug and play functionality, where if there are existing systems like SCADA or MES, we can make use of those industry standard protocols like BACnet to connect with those systems and collect the data. Or we can also add new layer of sensors and additional IoT hardware to collect the data. And this process starts right from the design, because we don't have to really wait to implement digital twin till the facility gets completed or facility is about to be operational. We can start this process right in the design phase, and the benefit that it gives is that we will be able to simulate some of the certain conditions, what if conditions. Like one of our customers, they are building a large hospital, and they wanted to understand, okay, during different seasonal elements that come out, how the hospital will actually operate, how my OPD department will function, what kind of patient load it can carry, what kind of operation theaters they can manage. So those kind of simulations, even before the construction has completed, they are able to do that. So that's the one advantage that we get when we start doing it in design phase. During the operational phase, we have all the systems ready. We can add more systems as are required, and that's where we are able to start collecting the data and do analytics part of it. That's where the data ingestion happens, and we can also convert that into intelligent operations. So Enviro-Optimus as a system enables your digital twin, implements and enables your digital twin to give not just the live information, but operations from disciplined operations, where those are more driven by humans, where we know that, okay, at certain time during the day, they will start few machines, and then after 2 hours, they will close it. Now, this is more like a disciplined operation. But from moving from disciplined operations to intelligent and optimized operations, that's where this digital twin and Enviro-Optimus plays a crucial role in the entire journey. So what is Enviro-Optimus as it is? So first of all, from having these static models, how we can make use of that data for your operations in the digital twin. So that's where Enviro-Optimus fills that gap. Second is fragmented OT systems. As part of facility, we have multiple systems. We have different firefighting systems. We have different HVAC systems. We have different systems for your STP. We have different systems for your steam boilers, all of these. Now, these are all disconnected systems. But then that's where a one unified platform is what is going to be required to do an overall assessment of the performance of the facility. And that's where Enviro-Optimus brings everything together as a centralized dashboard. And then further, it can be spread over specific roles. Okay, few facility managers can only look at few specific things which are relevant to them, as against the operations manager can have an overall outlook of the facility. So that's where. Now the trapped asset data. So most of the assets that we are using, equipments, instruments, they do generate this data, but then that hardly gets utilized. So that's where we are able to get that data and make sure that we are able to improve their performances, improve their lifespan. So because these assets are giving out data, are giving out their health conditions, but then utilizing them, that only will understand, okay, how they are working, and if they need any kind of maintenance, any kind of upgrading that is required. So that's where it helps in doing that. So those are the areas where Enviro-Optimus as a system fills those gaps which are typically there. So from BIM to intelligent operations. So as I said, in your as design systems, we don't have just the geometry, but we also have the asset data and specifications. Now this could be a BIM, or for industrial, it could be a different type of design data built using different systems like Plant 3D or Aviva or Smart Plant 3D and some of those. But this data, now using Enviro-Optimus, we can make use of this data right from your concept design stage and construction till your operations and maintenance. And the benefits that we get is, first of all, ability to optimize the energy. Okay, so typically we rely upon just the energy consumption and the bills that we get, but ability to take a granular look of all the equipments, all the assets, and how they are behaving, how the energy consumption is happening across them. That's where this digital twin brings a lot of value. Next is Enviro-Optimus has its own AI/ML based machine learning and predictive intelligence, where it's not just the past data, but using the past data, it will learn and at the same time it will also get the running data, the live data, so that it understands, okay, based on the past data, it will understand, okay, what are the different type of behaviors this particular equipment has, and if there are any anomalies, if there is an unexpected behavior, those will get reported so that we can avoid any unexpected downtime. So that's the important thing. And finally, as the facilities grow, we also want to make sure that our carbon footprint or our contribution to environment is somewhere also gauged, it's somewhere also measured. So that's where EnvirOptimus along with the digital twin helps in essentially monitoring your greenhouse gas emission goals as well as your sustainability goals, because that is something where all the large organizations are very actively working towards maintaining those. Now, one question typically for older facilities that is like, they may not have the design data, or they may not have the BIM data available. So what can be done? That is where EnvirOptimus supports using the point cloud data, which is captured using 3D laser scanners. So typically the point cloud data that gets captured, and that is being used as, one is we can convert that into a digital model, which is like converting into a Plant 3D or Revit model, and then using that. Or as a digital twin, we can also make use of the construction reality, which is scanned, okay, which is the scan data, and then define various assets into it, and then assign the real-time data to it. So that is also one way in which, for the existing facility, we can make use of the point cloud data or the scan data to convert that into a living digital twin. So one is, if the design data is available, directly make use of it, which is the excellent solution to it. But unfortunately for older facilities, we may not have that, but that's where that is also possible to convert that into a digital twin solution. Now, one thing, of course, we talked about the maturity level of digital twin. We briefly touched upon what kind of benefits it will give. But who are the persons who will actually benefit from having such a digital twin? And when we talk about the living digital twin, or the digital twin which is able to give out the information, give out the insights, that's where we see that when we talk about the health, environment and wellness aspects, that is where the sustainability officers who are essentially tracking the greenhouse gas emissions, who are targeting or who are looking at the measuring objectives which they have defined as part of their certifications, ISO 50001 or 14001, or those who are opting towards net zero goals, right? So that is where they will help, the digital twin will help them in automating this process, where it is able to capture and observe those, take those recordings and essentially convert that into compliance reports and automating that process. That's one thing. For operations manager, I think for them the most important thing is to have continuous streamlined operations, no interruptions, and that's where with the AI ML and predictive capacity, the capabilities, they can make sure that such downtimes are reduced, so that it helps in making sure that their production rates, their targets that they have defined, they are able to meet those, and unexpected stoppages don't occur. Facility managers, similar to operations managers, for them also making sure that the facility operations are smoothly running. The maintenance part is taken care of in timely manner, because most of the times the equipments get installed, instruments get installed, and then hardly someone looks at it till some error or some damage occurs. But that's where timely notifying those facility managers, saying that, okay, this asset needs attention, this is the vendor from which we purchased it, this is the cycle in which the asset maintenance should happen. That's where it helps. And finally, for of course all the CXOs, for them, of course, for their end goal is to how they can optimize overall consumption. Now, that consumption could be related to the energy, or it could be related to the sustainability factors like use of natural resources like water, natural gas, and so on. And that is where for them it gives essentially ability to measure the consumption and implement some of these insights so that they can optimize it, reducing the cost making sure that the operations are unhindered. So those are the people to whom this EnviroOptimus, the unified digital platform, works. Now, typical industries where we see that this is being widely discussed and people are keen to adopt it. So starting with commercial buildings and essentially the large infrastructures like data centers or critical infrastructures like airports, where the huge facility needs to be operated, multiple facility management teams are there, multiple levels of people are there, different systems are there, HVAC system is there, electrical systems are different, substations are there, chiller units are there, then there's a security staff, there are restricted zones, a lot of complexity is there. So that is where, and especially for data centers, for them, power usage efficiency, all of these things matter. So that is where having a digital twin adds a lot of value to there. When we talk about healthcare and hospitals, for them, making sure that the facilities are well maintained, noise levels, any kind of hazardous gases, the temperature and humidity parts are maintained. They are able to simulate the patient's incoming, outgoing scenarios. That's where having digital twin adds a lot of value. When we talk about industrial plants and factors, various sectors within it, whether it's automotive, manufacturing, or chemical, pharma, and food, everyone has a different requirement. As Shripad was saying, digital twin will need to be customized as per the sector. When we talk about pharma sector, for them, the compliances, certifications are at most crucial and critical than energy. But when we talk about automotive or manufacturing, for them, how they can save energy is going to be crucial. So that's where the platform itself has the ability to customize it so that specific use cases can be addressed and specific objectives which get defined during the installation itself or during the implementation itself are monitored, are paid attention to, and are fulfilled. So that's where the different use cases are there. Variety of sensors, meters, systems, whether it is ERP systems or asset management systems like IBM Maximo, we can do interface with those, take data from that. So evenly, in case, let's say, design data is not available and the data resides in Maximo, we can connect to that and get that data and make use of that data for the digital twin facility. Now, when we talk about, we talked about, a lot of benefits. We talked about, how to build a digital twin, but what are the impact? How the business gains out of it? So I'll say that first of all, sustainability part, we are able to monitor whatever we can improve. So it helps on the sustainability part, on the operational efficiency, proactive maintenance, and processing, improved process control using simulation. That helps in making sure that your production planning is updated, your downtimes are reduced, and finally the cost savings. So ability to switch between different power energy sources, whether it's a wind, whether it's a solar, DG, or from grid, and making sure wherever there are any power purchasing agreements, those are honored, those levels are met. We don't cross them so that we don't end up having penalties or pay extra. So those are the things where the having a digital twin powered by EnviroOptimus helps tremendously. Now I'll just quickly showcase some of the different screens that we can see as part of the digital twin. So one of the excellent features that EnviroOptimus gives is ability to see the energy flow end to end, right from your energy source. Let's say it's a grid or your solar panels or diesel generator. We are drawing that energy, drawing the power, but where exactly it is getting utilized, and ability to go till granular level. So I can really go down to a pump and say that, this pump in a particular month operated for say 45 hours and it pumped so much of water or so much of media, and this is the energy consumption of it, and this is the pattern in which it worked, right? So that's the ability to drill down that data, whether we do it on a daily basis or weekly basis or monthly basis. That's where, so this Sankey diagram that you see is done for one data center where we see that various energy sources, how they get utilized across their server racks, their CRHs, and server room air handling units and air conditioning units. So that's the one thing. As a part of digital twin, we can also visualize the live conditions. So what you see here is a heat map of one floor, and we can see if there are any cooling inefficiencies. This is just one example. Then especially useful for data centers, because for them, as their IT load increases, they also have to adjust the cooling, okay, the air handling and the cooling, right? So that's where understanding these inefficiencies becomes very critical. Now, and this is all backed by the real-time data that is getting collected. So we can see live data that is seeing all the energy meters, all your sensors that are connected. We can see the data live, spot values, real-time values. We can go back, see the pattern across multiple months, quarters, years, and so on. And this same data is fed to the AI ML engine, which is at the back end in real time, understanding the previous data. It has learned from it, and it is fed with the real-time data so that it finds any anomalies, it finds any unexpected behavior within the asset that we are doing. So just quickly, a couple of cases where we have implemented EnviroOptimus digital twin, completely end-to-end implementation, right from taking the BIM data, understanding the existing systems, taking all the attributes and parameters from BIM data for the equipment's assets, integrating that with digital twin, integrating their existing BMS system. So it could be like Johnson Controls or Honeywell or Mitsubishi. So different type of systems it can integrate. Take that data, integrate that into a tandem system where it starts giving the results immediately. So the implementation time is very short. Just wherever we require adding any additional sensors, we can do that and we can implement that. So this is like for one of our customers in Tokyo, we did that almost close to 1,000 data points that are getting collected. It also has AI ML engine, and it predicted some odd behaviors on a couple of floors, and we could collaborate, we could assess that with the results were assessed with the existing, and we could see that, okay, some of the air handling units were not working correctly. So that is how those corrections were they were able to do. Then again, this is in India for L&T construction in Chennai. Again, we implemented the entire end-to-end. In fact, this building was actually under construction when we started implementing digital twin for them. So even before the complete building was constructed, we knew what exactly the digital twin expectations are, what needs to be done, and how simulation can help them in terms of car parking lots, how the car parking will get filled during the office days, during the holidays, and so on, and how the wellness factors can be maintained across the floor. So this is a large facility, almost housing 3,000 plus personnel. So that's where we implemented the entire digital twin, and this is now about to reach the living digital twin level, where it will start automatically controlling some of those air conditioning equipments on its own based on the occupancy. So based on the occupancy on the floor, it will adjust the temperature levels, it will adjust the air conditioning levels, and so on. So those were some of the examples, and this is the last slide of my presentation. And I hope me and Shripad were able to take you through the entire journey of digital twin, the maturity model itself. What are the different levels within that? What are the benefits that we get, and what are the essential factors that need to be considered as part of the implementation? And we would be happy to take any questions that you may have, and please feel free to get back to us if you would like to go ahead with the digital twin, implementing digital twin in your facilities or your customers' facilities. And that's where we as a EnviroOptimus team can do the maturity assessment, existing assessment, where exactly do we stand, what are the objectives of implementing digital twin. We can also define a small pilot project where we can quickly, within few weeks, we will be able to implement it and and the end users will start seeing results. But this was the overall, as part of webinar, me and Shripad wanted to convey to the audience the digital twin maturity model. And we are now open for any questions. Over to you, Pragya.
Yeah, Didi. So we have one question. Like,
Yeah.
BIM is mandatory or other softwares can be integrated with DT?
Sorry, can you repeat the question?
BIM is mandatory or other softwares can be integrated with digital twin?
No, BIM is just given as one example. When I say BIM, it essentially is the design data. Now, it doesn't have to be BIM. It can come from other systems also. So as I said, like for industrial plants and facilities or factories, the design data typically will be in Smart Plant 3D or Plant 3D or Aviva Plant E3D systems, right? So that data can also be utilized, because finally it's the geometry and the asset data and specifications which is more important than us. BIM is just one example, and BIM typically will, when we say BIM, we will typically, our attention will go toward buildings, more on the buildings. But BIM is just one example that is given. We are not limited to BIM. Any design data can be utilized for implementing digital twin.
Okay, thank you, Didi. Any more questions? Please feel free to type your questions.
I see one more question saying that, okay, for older facilities, can this be implemented? Yes, I think when we talk about older facilities, or I'll say legacy facilities, maybe some of these facilities which were constructed maybe say 25 years ago or 30 years ago. Of course, at that time the BIM itself was not there, but most of the times the design data is more like a 2D based drawings, maybe done in AutoCAD or maybe even earlier. And of course, with that, all the assets and equipments which are part of this facility will also be older, I'll say, using old technology. So definitely based on assessment, we can, the solution, first of all, it has ability to do retrofitting, okay? So any existing equipments, assets which are there, based on the interfaces that it provides, those can be connected. So EnviroOptimus also has its own hardware which can connect to some of these legacy equipments and start collecting the data. So to answer your question, when it comes to assets and equipments, we can collect the data. When we talk about the 3D representation part of it, that's where we can always do the scan to model and scan to BIM process, where we do the scanning of the entire facility and convert that into a model which can be utilized as part of your digital twin.
One more question, Didi, is there? Is EnviroOptimus scalable?
Absolutely. EnviroOptimus has been developed in such a way that it addresses multi-region, multi-asset, multi-location scenario. So understanding, saying that, okay, let's say, because we recently started working for one electrical distribution company, and they have like thousands of substations placed across the geography, right? So that's where, when we want to do that digital twin for them, okay, our solution itself supports making sure that assets and all these facilities located at different locations. So just to give, like for our India audience, giving example, I may have few electrical substations in Nagpur, few in Thane, few in Kolhapur, and spread across, right? And then ability to have a central cockpit where the managers, the operations managers and facility managers are able to visualize the substation data, understand, okay, what is happening at particular substation, and unfortunately if some odd event happens, then ability to immediately take action. So that's where the solution supports multi-region, multi-location, multi-asset and multi-facility architecture. So as a let's say as a chief operations officer of a large chemical or pharmaceutical company where they have plants across India. Okay, that person will be able to see data for every plant which is there, or say a regional manager based in Maharashtra will be able to see data which is only for that Maharashtra plants in Maharashtra. So to answer your question, yes, it's a scalable solution. There are no limits to it. We can scale it to whatever level we want.
Okay. We have more questions, D. Will digital twins become a standard requirement in smart cities and infrastructure projects? Hello?
Yes. Can you hear me?
Yeah. Now,
Oh yeah. So that's a very good question. We definitely believe that it'll happen, except that it is probably the next step, because right now the industry is at a level where BIM is becoming a standard requirement. See, there was once upon a time the requirement was a CAD model. I mean, just a AutoCAD model was a requirement. Of course, I mean, another few decades back, it was all blueprint, ammonia blueprint. Then it became standard and a requirement to have an AutoCAD model. Now it is very soon becoming standard, especially in Western countries. It is becoming standard to have a BIM model. So 3D plus metadata, that is together is called a BIM model, right? Or there are other names for it. It is called MEP model, right? Mechanical, electrical, plumbing. In the manufacturing or the process world, it is called MEP. In the buildings world, it is called a BIM. But so we are right now at a level where BIM is becoming the standard expectation. I think the natural progression is for BIM to be connected to a real world system like SCADA or ERP, and then digital twin being becoming the standard. It's probably not standard now, but I think that is where we see the market going.
Okay. Thank you, Shripat. Next question is, who is practically maintaining the digital data and what prerequisite needed to create digital data? And how digital data and physical data talk in real time?
Okay, so let me get the question right. So I think there are three questions. One is, who is maintaining? What was the first question? Who is
practically maintaining the digital data and what prerequisite needed to create digital data?
Okay, so the digital data itself is outside the purview of the digital twin, because the digital data exists. So even if there is no digital twin, the data, for instance, what are the sources of digital data that come into the digital twin? These typical sources are, let's say, a BMS, a building management system that is monitoring things like access control, monitoring cameras, monitoring HVACs and all that. So this data it already exists. Now, having said that, if there is a building that does not have a BMS, okay, then EnviroOptimus has the ability to install all sensors and create an entire digital data backbone on its own. So having a BMS or having the digital data is not a prerequisite for EnviroOptimus. If it exists, then EnviroOptimus leverages it and it integrates it with itself. But if there is nothing, I mean, just imagine like a commercial building that does not have that has an HVAC but does not have a BMS, right? Then we would actually install the sensors and the IoT modules that will then pick up that data, in which case the answer to the question is, then we are responsible for maintaining the digital data because we are the one who instrumented the system. Okay, so in short answer is, whoever is responsible for instrumenting the environment is responsible for digital data. So the BMS belong to, say, Schneider Electric, then Schneider Electric or their system integrator is responsible for digital data. If we instrumented it, then we will take the ownership of it. But we will always remain responsible for the integration of the digital data. Okay, there was a second question, Pulja.
How digital data and physical data talk in real time?
Okay, so digital data and the digital world and the physical world. So let us assume that the digital, I mean, well, I don't know, what is physical data, but there is a physical world, and then the physical world is represented in the digital data, and the digital data is then reflected in the digital twin. So it's like three parts, right? So this communication really happens on, depending on what the data we are talking about. Every data source typically supports a specific protocol. So if you talk about BMS, then one of Didi's slides mentioned something called a connective tissue. Didi, if you can go to that slide which has a connective tissue, right? Yeah, next one. Yeah. So this is the connective tissue is actually the short answer. So there will be devices that talk Modbus, the devices that talk BACnet, MQTT, OPC UA. So for these devices, that respective protocol is used. In fact, EnviroOptimus really does not have any control on where the digital data, in what kind of system the digital data is implemented. So that is why we have to cater to a wide variety of digital data sources. And that is why we have to cater to a large number of protocols. So this is usually there is a direction called southwards. Southward direction means towards the field, right? So these are all southbound protocols, which is looking south towards the field. Then there are also northbound protocols. For instance, some of the data from about the physical world will also come from transactional systems. Like I mentioned, apart from the RPM of the motor and the current of the motor, there is also very valuable information about when was the maintenance done. Now that information is not there in any southbound system or any shop floor system. It is usually there in an ERP system like SAP PM or IBM Maximo. Now there the protocol that will be used will be an IT protocol, like a web service call, right? So there, or an API call to those systems. So the answer to the question is, depending on what system that information is coming from, we deploy the appropriate protocol to extract the data. Okay, and then there was a third part for the question.
Okay. Another question is, Shripad.
Yeah, that was go ahead.
What ROI achieved by customer? Can you share some cost-saving examples?
When we talk about the ROI, I'll give you examples from our implementations itself, right? So for the customer where we implemented in Japan, immediately they were able to see 8% improvement in their energy consumption in about first 6 to 9 months, okay? Because of the intelligent switching on off of their air conditioning units, understanding based on the various weather patterns, what kind of air conditioning requirements are there, and further based on the occupancy based lighting and air conditioning, they were able to save 8% in the immediate, and in the following years incrementally they are seeing 3 to 4% improvement, because as the data is getting churned, more and more insights are coming out. So that's where initially they saw 8% improvement in their energy consumption. So that is where the cost reductions happen. And year on year, they are seeing additional 2-3% or 4 to 5% improvement that is happening on the energy consumption and the resources side. So that's the one ROI that I can talk about.
Yeah, I also want to add a little bit to it. So, in the market we see, so ROI is obviously, there are two types of ROI. One is obviously very, very hard quantifiable ROI, like energy consumption, which is very clear, it can be quantified. But if you remember one of the slides where I talked about the use cases, there were 3 use cases that I talked about. There are many existing, but we talked about 3. So we talk about those very 3 use cases. One was asset maintenance optimization. Now there the ROI can be calculated for a specific case. So like for instance, if any of you in the audience want us to take a look at your environment and tell you what your ROI is, that is definitely something that we will do, rather than giving specific number. Energy is simple example where ROI can be easily calculated. But there is a third use case, which is operational efficiency, where several of our customers are using digital twin to just improve responsiveness. If you have a very, very large building, and in a very large building, there is in one corner of one floor, there is a compressor or there is a motor that is getting heated. It is very important that the maintenance personnel very quickly understand what is happening and where it is happening. So the geographical location of where it is happening, which floor, which corner, and what is happening, that will decide how quickly they can respond. So I think this is one of those areas where ROI is sort of qualitative, but it is very, very critical. And these kind of digital twins are being used for completely non-process oriented I would say activities and predictions. Like, for instance, we had once given a quotation for a soccer stadium in Saudi Arabia, where they were trying to use a digital twin to predict how quickly those people, whatever 30,000, 40,000 people, how quickly they can exit from the stadium in case of a fire or in case of something. So those kind of simulations also, they are possible with once you have a digital twin. So while EnviroOptimus doesn't kind of participate in those kind of things because it is not process related, but the basic digital infrastructure, twin infrastructure remains the same for this. So that is another sort of additional bonus ROI that most customers can expect.
Okay, thank you, Shripad. So now the last question is, how do BIM integrated digital twin platforms address data security, especially when handling sensitive infrastructure information?
So one, the question is like what is the data security part of it? So in EnviroOptimus as on its own, of course, it supports some of all the industry standard protocols which are there. But at the same time, there is also provision to add a special security layer where all this real-time data is encrypted and stored and passed on through the systems. That is one part of it. At the same time, now digital twin, this can also be implemented as part of your on-prem infrastructure. EnviroOptimus also supports creating a separate data fabric altogether, where it remains isolated or it remains separate from your network or your facility network, so that there is no penetration. There is no possibility of having any penetration within the network, so as to avoid any kind of your sensitive data to be leaked outside your network. So from data security side, we have the specific methods in which we make sure that the data is encrypted, data is managed, and data is accessible only to specific consumers. Now, when I say consumers, these are the users within the digital twin ecosystem which is going to get implemented.
Okay. Thank you, Didi. Now we are at the end of the webinar. So thank you everyone for joining us today. We hope you find the session insightful and valuable. If you would like to explore this further or request a demo of EnviroOptimus, please feel free to reach out to us. Thank you everyone for joining the session. Have a great day ahead. Thank you.
Thank you.
Thank you everyone.
Thank you all.
Appreciate it.
Appreciate your time. Bye.